You might not have a battery attached to your house, but that doesn't mean your house isn't being powered by one. Let me take a step back. Think of a windmill, one of those big ones that generates power. And they can generate a lot of power. A single tower with a wind turbine attached can generate more than 5 million watts of electricity these days. Enough to power about 500,000 standard LED light bulbs when the wind is blowing. Wind power and solar power are on the rise. They're clean, they're affordable, and they've reached a scale that rivals fossil fuel power plants. They are the fastest growing sources of electricity around the world, but they present a challenge of their own. Now, think of your house. When you press a light switch or the button on an appliance, you want that electricity now, whether the wind is blowing or the sun is shining. If you could somehow store that energy the windmill produces, you could make sure it's available when someone presses a button. The question is, how do you store it and where do you store it? This is where Transalta's wind charger project comes in. The idea is simple. You produce power at the windmill and you store it at the windmill using batteries. A little island of wind-powered renewable energy. We spoke with Dan Martin and Chelsea Donelon of Transalta Energy to discuss the wind charger project, the art of time shifting, and how to power homes with wind, even when the air is still. In this episode, the first of our two-part series on electrical energy storage, here on Carbon Copy.
Hi, I'm Chelsea Donelon. I'm a Senior Advisor, Carbon Policy, Technology, and Strategy at Transalta. So I think about our 2030 and 2050 climate goals and how we're going to reach them.
Great. It's wonderful to have you on the show. Dan.
Yeah, thanks, Mark. Dan Martin, Capital Projects Manager for Transalta. I get the pleasure of leading our execution projects. Most recently, Wind Charger, project we're really proud of. Also leading wind and conventional fired generation projects across North America.
Chelsea and Dan, it is great to have you on today. I look forward to the conversation. So, I'm going to jump right into the questions. Transalta is somewhat of a household name in Alberta, but can you give me a sense for the breadth of the organization and the role Transalta plays providing electricity for businesses and residents across the province?
Absolutely. I can start with that if you want. So yeah, Transalta, long-standing company, as we all know, well known in Alberta. Quite a diversified portfolio we have, starting with hydro. The fire generation's a solid backbone of our asset base. And over the last 15 plus years, we've taken a strong growth into our renewable sector, the largest wind producer in Canada, a wind operator in Canada. We've been in wind since the late 90s. We also have a solar asset in the U.S. and active in the Australia region, primarily Western Australia, as well, with a recently announced battery and solar integrated project over there.
Excellent. So as one of Alberta's largest and long-standing electricity suppliers, you've seen firsthand how Alberta's electricity system has and continues to evolve. Can you paint me a picture of how electricity generation is changing over time in the province?
Yeah, so electricity has really transformed in Alberta, and it's transformed a few times, right? So Transalta has the vast majority of the hydroelectricity generation in Alberta, and those are really the original generation in Alberta, right? Dating back to, 1909, early 1900s, right? And then it transformed into coal and then gas generation with, relatively cheap coal and good access to gas in Alberta. And now we're really in our, third transformation of the electricity sector in Alberta. And that's where we see huge numbers of renewables, wind and solar coming in, and just a wave of new technology that are looking at how can we generate electricity with less greenhouse gas emissions.
So with that change that's happening over time, can you tell me how Transalta's portfolio of projects is also changing. And what is Transalta's vision for the next 5, 10, or even maybe 20 years?
I think this is such a great question, Mark, because Transalta is right in the middle of really an unprecedented transformation, as is Alberta as a whole, right? So in 2015, 2016, the NDP and federal governments decided that there would be a phase out of coal-fired generation in Alberta by 2030. The last, coal assets were built in this province in 2014. And we will, as Transalta, be off of coal by the end of this year. So we'll be 9 years ahead of schedule, which is really an unprecedented pace of change for a company and for a grid, right? To have gone from building these types of assets to being completely off of coal in less than a decade is something we're really, really proud of and has allowed us to dramatically reduce our carbon dioxide emissions. So we will be 25 million tons below our 2005 levels by the end of this year. That is huge. That is one of the biggest emissions reductions by a single company in Canada and indeed in the world. So we're really proud of that. But because we're kind of in this middle of this coal transition and a lot of those units are converting to gas to ensure that we can continue to provide reliable electricity for Albertans, we're also really thinking about what does the next 10 years bring? What does the next 15 years? And we know that our coal transition is not the end of our decarbonization journey and that we are continuing to push ourselves to find out what are the new technologies that are coming online and going to really explode in the next decade. And our wind charger project was a great way for us to dip our toes into battery energy storage and how it can complement wind and solar assets that we already have.
Well, what an exciting place to be in the midst of such a landmark transition. And that's a really great lead into the project I wanted to ask you about today, the wind charger project. I understand that Transalta recently completed a very exciting project in partnership with Emissions Reduction Alberta. Tell me about that project. Tell me about Wind Charger. What did it involve?
Absolutely, Mark. So Wind Charger for us was a project that we looked at it. We found a way to make it happen. We had a ton of passion for this project. We're very proud to be a part of it. Definitely it had its challenges to get going. I guess I'd bucket those into two groups. There was the initial challenges. Cold climate. We all know batteries don't really like the cold. So that was the challenge. How do we address storage in this climate? There was no regulatory framework at the time when we embraced this project to support energy storage. Safety is a huge priority for Transalta. It is and always will be. So how did we design and build a new battery storage project with the cold weather climate and just the emerging technology that was a very safe installation? And the last one was the economic piece. It was definitely a challenging one for us to get across the line economically. And for that, definitely have to take a moment and thank Emissions Reduction Alberta, because your involvement in this was a huge opportunity to get this new technology going forwards. So I guess that was the initial challenges. And then I think about during construction, God, it was fun, but it was challenging. It was nice that it was close to Calgary, so we could get there. Our travel restrictions were minimal. We did start this construction early into the days of the COVID pandemic. So we were able to build this. Supply chain challenges, travel restrictions, and just the safety considerations of all the distractions with the COVID situation. Really proud. We had no COVID cases. We had a safety incident-free project. Very proud of that. And then I guess the last piece was the new technology piece. Trying to bring on new technology always has its challenges. It wasn't just the batteries, it was the selection of the batteries, it was the integration of the technology into the existing operation through a somewhat first-of-kind transformer design suited for this application, and just the full integration into our data and control system. So those were really the challenges and the excitement that we were able to work through.
It's a very impressive health and safety record on a project of this size and scale. So maybe if it's all right, can we dig a little deeper on the project itself? I'd love to learn more about what the project involves, what it's trying to accomplish, what stage you're at now, and other elements of the project that you're able to talk about.
Absolutely. So yeah, the project's been operational since October of last year. We've had a great experience with the site operations to date. We ran through a very harsh winter and some hot summer days. We've certainly seen the range of temperatures experienced. The site was very reliable through that. The basic premise of it is we're connected to our Summerview wind farm. So the batteries are charged off our wind generation. So it's a 100% renewable project. So the basic premise going into this was we would take the wind generation, which doesn't always produce. The wind doesn't always blow when you need the power most. So we would basically time shift when the power was generated versus when the market demands were at their peak. So essentially the battery is connected behind the fence. There is metering to make sure all the flow of energy is fully metered, and work closely with the ASO to establish those requirements. And then I guess the big benefit we see is emissions reduction, right? Like that's by time shifting when we're producing versus when the market needs it, we are offsetting some of the higher carbon generation that typically had filled those high demand periods. So we definitely see projects like this as a important part of the renewable sector going forwards.
Yeah, thanks very much, Dan. Just want to make sure fully understand. Can we talk a little bit about the greenhouse gas reduction aspect? Emissions Reduction Alberta, that is core to what we do as an organization. Just want to make sure I understand. So when the wind is blowing, you charge the batteries, and then when the wind isn't blowing, you release the electricity onto the grid and effectively offset or displace some other forms of electricity generation that have a greenhouse gas footprint. Is that correct?
That's exactly, yeah. We looked at the Alberta grid intensity, which is a published document on the annual amount of CO2 that comes with the power generation in Alberta. So we looked at that, and then I think we have published these numbers. So we had about 26,500 tons of carbon reduced by offsetting the times when typically you'd be relying on the higher carbon peaker generation, that by time shifting when we're able to deliver the energy from generation to the time when the demand for the energy is highest. By time shifting that, we're offsetting the higher carbon. And we did look at the total carbon emissions footprint of the battery production and the recycling, and even with those in, we're about 24,500 tons of carbon reduced is the numbers that we've calculated internally. Yeah.
Well, it's very exciting. So if I go back to the thoughts around the near-term, medium-term, and long-term vision, can you maybe elaborate a little around the importance of energy storage in Alberta's future electricity system?
For sure. So I think we see an important role for energy storage in Alberta and indeed globally. You can look at many international publications from the IEA, from NREL in the US. They're all saying, 10 to 15% of renewables, will end up being stored in battery storage. So we know that there is, hundreds and thousands of megawatts that will need to be in battery storage. And we really see this driven by a couple of things. One, we see our customers, particularly corporate customers, really demanding to have more wind and solar and be able to tie their operations to those types of generation facilities so that they can report to their investors their ESG performance there. And so we really continue to see a large growth in supplying customers with wind and solar assets and various intermittent renewables. That means that you also need to think about how are you integrating that into your system. So as Dan has said, the wind is there when the wind is blowing and the sun is there when the sun is shining, and they're not there when those two weather events are not happening. But we do demand power, both as Albertans and as Albertan industries, 24/7. At any hour of the day, you can go home and turn on your light. And it's our job as Transalta to ensure that you can do that. And so as we look at battery energy storage systems, whether they are, this Tesla lithium ion that stores for a relatively short amount of time, in that 2-hour range, or, emerging technologies that are looking at longer duration storage plays, we're really thinking about how can we provide our customers with eventually 24/7 green electricity. And we see just the beginnings of demand for that, right? Google has published that they will be looking to procure 24/7 renewable electricity. They want not only to procure enough renewables to offset what they're taking from various grids around the world, but they also want to do it in the hour. And so when you look at how are you going to meet that demand, there will definitely be a role for batteries to play in solving that problem, for that challenge.
Yeah, thanks very much. So in this project, I understand that you've installed the batteries right at the location of the wind farm. Can you talk about the advantages of that relative to, for example, the idea of all of us having batteries in our houses, for example?
Yeah, so I think that there's a few advantages, and Dan, feel free to join in if I miss anything here. So the advantages for us of putting wind charger right at our Summerview facility was that you know that what you are putting into that battery is 100% renewable electricity. You're not storing other forms of electricity, you're doing it at site, which means that you're also helping the transmission system to be able to utilize wind more consistently through the hours. So, whilst we're not really seeing this yet, we have seen in other jurisdictions where, you have a lot of wind and solar built, that those can get stuck down in the south because you don't have enough big transmission wires to pull them out to where your loads are. With a battery, you can take some of that wind that could possibly be curtailed, and that curtail just means that you throw it out instead of using it on the grid. And you can store it for an hour when it is needed. And so by co-locating these facilities, you allow yourself to really maximize the use of our renewable electricity. It also has some helpful pieces in terms of being behind the fence, which means we don't get charged the same rates as we would if we were on the grid ourselves as an asset, where you'd get charged both to charge the battery with electricity and to discharge. You avoid that challenge when you're coupled with a wind farm.
So there's a cost advantage as well.
And there's one other advantage I might add in is just the footprint. I had the pleasure of spending a lot of days at the site, and it's a relatively small footprint. A wind charger can supply the town of Pincher Creek, all the homes, for about an hour and a half. So if I think about the footprint of our wind charger site versus what it would take to put those individually at every house, there's a great efficiency benefit in centralizing it and doing it at a utility scale versus doing a lot of small ones at each individual home. So I think that's a really good benefit as well. Yeah.
You mentioned this is at a wind farm, and you also mentioned solar power as well. Is there an opportunity to replicate this project with solar power or even other forms of generation beyond wind?
Yes, I think we see the ability to replicate this project at a variety of our facilities around the world, and indeed potentially someday as standalone batteries as well.
Yeah, I look at battery storage as a bit of a Swiss Army knife of storage. It can fit so many different applications. Like we're installing one now in Australia tied to a solar installation that is all part of the project there, and I'm aware of other ones in Alberta that are all tied in different ways. So we all know about the NMAX one in Crossfield. Again, that one's tied to conventional turbines. So really, the Swiss Army knife, it can be used in so many different ways. Yeah.
So the batteries are up and running now at Wind Charger, as you talked about. Can you tell me, beyond, you talked about an impeccable health and safety record, which is, again, impressive. But how are things performing at the facility? Have there been any surprises or unexpected outcomes in the way the batteries interact with the wind farm or the grid, for that matter?
To that one, I would say everything is going as planned. There was a lot of upfront work put into the project to truly coordinate. I think we're really seeing the benefit of that early communication, lots of coordination with the ASO, yourselves, the contractors that installed it. Our operations team were a part of it from its design through execution. So really good integration with all those key stakeholders, and the site really has operated quite seamlessly. Yeah.
Oh, that's excellent. So you talked earlier, Dan, about a number of challenges and obstacles that you faced along the way in terms of bringing this project from concept all the way to reality. Can you maybe shed a little bit of light on how you managed to overcome some of those hurdles and maybe what some of the biggest learnings that you've had along the way are?
I think, they were all somewhat anticipated with new technology. The biggest learning, which is just a not really a learning, it's just a good way to approach things, is we were very efficient in how we approached the project, but we also collaborated quite actively. Transalta brings just the experience we have as a long-standing power generator, from knowing the markets to knowing operations to projects. We truly had the full piece to bring it all together. So really, I think it was just the challenges were there, but probably the biggest challenge was just getting a cold climate installation. When we started this project, the name Megapack wasn't even a known name. They had a power pack, which is a big fridge essentially. So the Megapack, when we first heard of it, we weren't allowed to use the name. We were under NDA for that. We went through a very rigorous process to select the batteries. There's a lot of, as Chelsea has mentioned, there's a lot of different options for energy storage. The Megapack's certainly not the only one. There's different forms of battery storage and energy storage in general. So we went through a really rigorous selection to end up with the Tesla Megapacks. They suited its application well, had a high process safety consideration, and there was a lot of design consideration to meet our temperature requirements.
I would also add to that, I think one of the biggest things that we all collectively learned in the Alberta system was just what it takes to put new technology on the system. And by that I mean our regulatory and policy framework never contemplated batteries when it was originally designed. And so not only did we need to learn about the technology and how it worked and how it would integrate with our existing assets and with the system in terms of generation and electrons flowing and electricity, but our system operator, the Alberta Electric System Operator, ISO, and the AUC, who approve these types of projects, all needed to learn about what they needed to consider, what were the appropriate metrics, how it would be integrated into, how the ISO manages all of the assets in Alberta. All of those pieces needed to be worked through, and so we had to work, as Dan had said, very closely with our regulatory partners, with the government, with the ISO, and of course with Emissions Reduction Alberta as well.
Yeah, that's a great point. There was a lot of days of us and Tesla, our engineering contractor, and the ASO all sitting down, sharing data, working through that very, very openly and collaboratively. Yeah.
Emissions Reduction Alberta takes action on climate change and supports economic growth by investing in clean technology solutions that reduce greenhouse gas emissions, lower costs, attract investment, and create jobs here in Alberta. These investments help innovators develop and demonstrate technology that can lower emissions at home and be exported to the world. That's why we've committed over $820 million to more than 220 projects worth a total of $6.6 billion. To learn more about Emissions Reduction Alberta, visit eralberta.ca. You touched on the partnership, well, a number of partnerships and collaborations there, but in particular the partnership with ERA. I'd love to hear your thoughts on the role that ERA's funding played in making this project a reality. Would the project have happened without that funding?
I wasn't at the table on the project side and at the time, but from everything I've understood and come to learn through the project, I would say no, it wouldn't have. We were quite challenged on the economics with the framework that we had to work with at the time, and I don't think we would have got it across the line. It took quite a bit to get this project across our investment committee at Transalta, being a first of kind for all the reasons we'd mentioned. Without the funding, I really can't see that. The numbers I've seen, it was a lean project as it was with the funding, so I really couldn't see it going ahead without it.
Yeah, maybe just to add on to that, I think as we look at technology in general, they often need support in their early days, right? Those first wind farms that we had in the late 90s, early 2000s, they were supported by some federal tax credits. And similarly here with batteries, we see them just not having come down that cost curve enough yet, even now that we've built our first utility scale one, to be able to stand fully on their own 2 feet. Now they are certainly coming down, and we're also learning about all of the value that they can provide to the grid and stability and reliability and how to pay for that. But when you have a first of a kind technology that is, early on its cost curve, not necessarily at the scale that it will end up at, you need those types of government supports in order to bring them on, in order to learn about all of the value that they can bring to the system.
When will you know, and how will you know if this project is a big success?
I would say we're already there. We've been running since October. We've got, our numbers. We do look backs on the project. We delivered the project on budget. We're actually slightly under, and so that was a good testimony. A first of kind project that came in with very lean numbers. So that's the first key one, is we came in on budget, and the ERA was happy about that as well. And we've had some runtime on the battery, and it's certainly meeting our expectations. So.
Now that you've done the first large-scale electricity storage project at a wind farm, what's next for Transalta in this area?
Well, we did mention the one in Australia. We have publicly released that we're building a solar battery there, and I've been engaged with the Australia team supporting that one based on the learnings from this project from mid to late last year. So that was the first one, and maybe Chelsea wants to take the more global view.
Yeah, I would just say what's next in this space, on batteries specifically, we continue to look at them, continue to look at opportunities, in Alberta, around the world, of where we can do more of these types of projects, because we do consider this a success. I don't have anything other than the Australia project that I can publicly talk about at this time, but we are, excited about how this one has turned out, and looking if there's other places that, we can do more in this space. I think more generally, we're really looking to challenge ourselves on, what, not only in the battery space, but in new technology together, what are the big plays that, have huge growth potential in the next decade, right? In the early 2000s, we invested in wind before anyone knew it was going to be a thing, and that turned into, a $5 billion Transalta renewables company. And we think that we're at a similar space here with technology, that there are technologies that can have that type of huge and impactful role to play in the electricity system in the future. So we're actively evaluating and looking to play in that space.
Can you give me a sense for the scale of the opportunity or the future need for electricity storage in the province of Alberta? Is it on the order of, I don't know, maybe 1 megawatt, 10 megawatts, 100 megawatts, any it doesn't have to be an exact number, but any sense for the scale that you think we'll need over the coming years?
Yeah, I think it's definitely already bigger than 1 megawatt, since Wind Charger is a 10 megawatt, 20 megawatt hour battery. We think it has a substantial role to play on Alberta's electricity system.
Yeah, and worldwide as well. We know what's going on in the States. There's a huge growing installation of battery storage. Australia, there's a large one underway there. There's worldwide, we're seeing a demand for it, I think.
If someone wanted to come see the batteries in the wind farm with their own eyes, is that possible? Do you provide tours of the facility? Are you able to see it from the highway? Any sense for that?
Yeah, it is visible from the highway. It is a fenced. It is part of the substation, so it is classified as a substation. So we don't officially do tours, but we certainly have hosted certain tours there. We had the Calgary Herald down. I believe CTV News was down. We've had a few parties on the ERA. You had yourselves were down there to see it. So we've certainly hosted people, but we don't officially do tours because it is part of an active substation. But certainly visible from the road, and we're glad to entertain people that want to come see it and coordinate that through our operations team. Yeah.
What's been your favorite part of making this project happen?
I think for me, I just love talking about this project. It's not our biggest project. If you look at a capital base, this is a commercial scale pilot, but it's just a very exciting project to be a part of something so new and to really go into it. And we all had to learn as we went in so many ways, and we all just worked together and pulled it together. I think we internally say we found a way, and that was the fun part of just embracing something that you didn't have a full roadmap on, and just working with some great people, some great partners, and making this project come together and having a really positive outcome that we're really proud of. Yeah.
Is there anything I didn't ask about that you'd want our listeners to know?
I think for me, I mentioned the partners in it. We talked about the ASO. Obviously, Tesla became a partner. Emissions Reduction Alberta, invaluable partner in this. I think also our installation contractor, Iconic Power Systems, they were They were a fabulous company to work with. So I think I want to thank them and BBA Engineering, who they supported us in the detailed design phase and in the advanced development scoping of the project. So definitely want to thank all the key partners that made this project successful. Yeah.
Well, Chelsea and Dan, thank you very much for joining me today. It's always exciting to talk about this project, and I appreciate you taking the time to have a conversation with us.
Thank you.
Thank you.